Welcome
to the joy of coding.
Hello, and welcome to episode 267 of The Joy of Coding. My name is Mike Conley. It's so good to see you. So good to have you here. Going to be hacking on some Firefox stuff, answering questions, maybe fixing some tests. Who knows what's going to happen today? I'm really looking forward to it. I hope you are too. Let's get started. Let me start by sharing my screen and showing you the agenda. So we have a bit of a preamble for every stream for the folks who are new. So I apologize if you've heard this 266 times before, but here we go. So welcome to the stream. No plan survives breakfast is kind of the philosophy behind this stream, where, you know, I think I know what I want to do. I think I have a general sense of the things I want to touch on today, but this stream is not really planned. Things could go wrong. I could get sidelined. I could get sidetracked. I might spend more time on one thing and not get to another. Who knows what'll happen? We're capturing software development in the raw, unrefined, warts and all. So if that's your bag, welcome. That's what we're doing here. That's the first thing. The second thing is about the agenda. So this agenda that we're looking at, which is like kind of a vague sense of what I want to do and also lists handy links for you, this is something that you have access to. So if you're on YouTube, check out the video description. And if you're on Air Mozilla, check out the details for the video. And if you're on Twitch, then I believe, if presuming that my Twitch chat mirror bot is working, which it is, yes, you should now have that link to the agenda in the Twitch chat. So go check that out. What are we doing today? I want to just jump right into it and talk a little bit about this first one, because this is something that we kind of have to fix ASAP. I wanted to save it for the stream, but you know, we got to fix it soon, and I'll explain why in a second. Let's pull up the bug, and then I'll talk about what's going on. So this was opened 8 days ago. I assigned myself just yesterday. I guess I this kind of got lost in my email, unfortunately. But basically, we have a telemetry probe that's going to expire when Firefox 96 becomes nightly. And it also causes, whenever a probe expires, this particular probe has a test associated with it that tests its capabilities and you know, tests that the probe is actually measuring properly. And so that test will fail if the probe expires. And so that's not good. Now the good news is that nightly, if you're like me, you're riding, I'm a little out of date, but I'm riding yesterday's nightly, and it's 95, but 96 is just around the corner. If we pull up the release calendar, you'll see that 96 is supposed to merge on the 11th. Sorry, not on the 11th, on the 1st of November, and today is October 27th, so that's only a couple of days from now, plus the fact that this Friday I'm away. In fact, most of Mozilla, a lot of people at Mozilla are going to be away on Friday, so we're not going to be working. So I've really got today and tomorrow to get this fixed. Now the good news is removing or updating probes is pretty straightforward, and we did this in a couple of episodes ago, if I remember correctly. If I go back to like episode 263, yeah, back in episode 263, so about a month ago. Well, it's not super surprising that it was about a month ago, because this sort of thing happens every time a release cycle occurs, where we hit an expiry, and this is no exception. We're about to hit the end of a release cycle, or a version cycle of the browser, so that's why we're hitting this. But it's a lot of similar techniques here. There's a link in the 263 episode guide to our lean data practices if you have questions about, you know, what we're doing with the data and what's captured and whatnot and how it works. You should check out episode 263. And let me tell you just briefly what this probe measures. We can actually pull it up and look at it. So it's a scalar probe. It's one of our scalars. That means that it's just a single number per telemetry packet. Like, telemetry will send a as opposed to like a whole series of numbers, like in an array where like every time an event occurs, like maybe every time you use picture in picture, we like add a number to a collection. This is just like a single number that's sent out. And what it is the maximum number of picture in picture player windows a user has had open at any one time during a particular session. And it's currently opt out. And it is for Firefox, and it only records in the main process, and it expires in 96. And so what I think I want to do is similar to oh, and actually this one expired. That's interesting. We let this one expire. That's fine. I guess we didn't need it. There were some other probes that the closed method and the open method, we let those all expire. That's interesting. What were the ones that we recently renewed? What was it? Because we recently renewed some. Let's pull these up. Oh, thank you, Smurf wishes me a happy Friday in advance. Thank you very much. So it was the events for creating, resizing, and moving. So what we can do then is take a look at what we did here, where we did a data collection renewal request, and it's a very straightforward process where we ask our data collection, our data stewards, to approve our change in the data we're collecting. So I'm going to refer to this comment. So I'm going to say such and such per bugs comment 3. I'm going to update these probes and make them stop expiring. Okay. So when you update a probe to make it not expire, what that means in practice in the patch is instead of having a version number for the expiry, you just say expiry never. Expiry version never. So that's the first thing we're going to do. Is we're going to open up scalars, YAML. Oh wait, do I have a up-to-date version of the tree here? Let me just double check what my version is. This is from yesterday. Should be fine, but let me, you know what I'll do is I should have built this before I, you know what, it's fine. It's fine. I can just apply it here. These files don't change much. So I'm not worried about conflicts. Picture in picture. I should probably remove these probes. You know what I'll do actually is I will file a bug for these probes to have Ramon figure out whether or not we actually want to bring these probes back to life, or if we want to just remove them altogether. But in the meantime, that's not the focus of this bug. I don't want to get sidetracked. So the first thing we do is we add the bug where we're changing the behavior of the probe to the sort of the bug list, the bug numbers here. That's a policy. And then for expires, now in the other patch we had like expiry version. This one's just expires, I think. I don't know why we make that distinction, but yeah, we just say never whenever we want it to never expire. So never. And other than that, I think that's all we need to do in the actual scalars YAML file. So we can commit that. That's very straightforward. So hang on, let me bump up the font. You can see what I'm doing. So what we do is we say hg commit, and then the bug number was this. Make the most concurrent, what was it? Most concurrent players probe, picture in picture, scalar probe, never expire. And then I'll have, actually I'll have Mika review that, and then we'll do data review will be, who did the last data review on these? Data review is from Megan McCorkadale. Okay, so I will do the same thing because Megan McCorkadale probably has context. So data review, nope, I must not have copied that properly. How do I, there. And then data review equals M McCorkadale, R M Tigley. That's how we say like data review is coming from Megan McCorkadale. And that the reason I put an equals here and not an equals here, that's kind of habit, but data review is not a thing that Fabricator and Bugzilla. So like Lando does the right thing whenever a review has been approved or a patch has been approved, and you and it lands the patch by updating the commit message to change the R question mark into an R equals. R question mark is how we basically, it's old school Mozilla speak for requesting review from, and then the IRC nick or the matrix nick of the person, or the username nick in Fabricator. And for data review, we don't have that support. So I'm assuming I'm going to get data review approval, but I won't land it until I do. So we can create that patch and post it up for review already. That's no problem. How's my microphone volume, by the way? I upped the sensitivity of my mic. I had the opportunity to rewatch last week's stream just to try something, just to see how something went down. And I noticed my microphone, and maybe it's been this way for years, but I think it has to do with the positioning of my microphone lately, that my microphone is quite quiet. And so how's my microphone volume? I'm curious. Is it too loud? Is it not loud enough? Do you have to crank your speakers? What's happening? Okay, so that's the patch. Very simple. And we will submit that. No problem. And then we have to actually do the data review request itself. Smurfy says, sounds good. Danny Colin agrees. Fantastic. So the data review request is very straightforward for a renewal. This is a pre-existing probe, meaning that the questions I have to answer, there's fewer of them. You have to answer a lot more questions whenever it's a new probe. If we're renewing one, it means it's been approved in the past. So I can just answer only a smaller set of questions. So what I'm going to do is I'm going to attach a data collection renewal request, and then answer these questions. Provide a link to the initial review data collection review request. So the initial request, I would imagine, is encoded. It's inside the first bug that was ever filed for this probe, which would probably be this one. Yeah, data review request. So let me supply that. The collection will now never expire. Product themes. Page worth perpetual measurement, since it's a well-loved differentiating feature that we still want to iterate on and improve. And then I will have a data review flag for M. McCorkadale and submit. And that, friends, is how that's done. So we are now waiting on a very straightforward code review and then a very straightforward data review, and then we can land this, and then Bob's your uncle. All right, so that one's done. That was easy. That was easy. The other thing I wanted to look at today, I've got. Let me pull this up in my dashboard, and then we can take a look at it. It was a. Oh, that's interesting. This is a new need info I had. This is something that I was need infoed on just a few days ago. Let's take a quick peek here. 6 days ago, open Firefox, enable the menu bar, open bookmarks from the menu bar, enable high contrast, and click on the bookmarks menu bar. The panel is displayed as expected. The panel is slightly cut off. The push log shows that the regressor was from me, from the Proton context menus, let's see the video. High contrast mode, turn it on Windows 10. Oh, I see, and then they get cut off. Interesting, the icons are still there. That might be why. No, I'm wrong. Those icons are still there. Huh. Interesting. What I'm gonna do is need info Mika, who is working with a set of students on improving high contrast mode on Windows, and has anything like this shown up on the radar of the folks working on high contrast mode? Would it be possible, if there's time, do you think that team would be interested in taking a look at this one? So, 2 requests to mTiggly in one Joy of Coding session. Very nice. So cleared that need info, and then the other thing I wanted to look at was, yes, a test that I wrote that is failing periodically, and I never got like a really good explanation for it. Oh, and then it was disabled. The test was, I guess I took too long to answer it, and so they disabled the test. If OS, it was skipped if we're on Linux 64, which is the only kind we build on, and Windows. So it only now runs on Windows and not debug. So only on Linux 64 opt and Win 10 opt. Right. So that's something we can look at today. How frequently was it failing? It was 37th most frequent failure. And then it just got disabled. Okay, well, we can try and look at that today. Let's see. What would I want to do? I mean, ideally we could reproduce it in like a Actually, you know what? I think we worked on this. I think I investigated this not that long ago and then pushed to try. Yeah, here. And I was trying to add logging for it. Search for an orange. And did I ever... These artifacts all got thrown away. This is like a month ago, so the artifacts got thrown away. I think. Ooh. And what was I doing here? I was like adding logging. I added logging here. Yeah, let's push this again. It's been a little while, but like here's my solution, or what I'm thinking so far. This logging is interesting. I guess I just never followed up on this because I pushed and then it just like sat here. I probably should have like tried to retrigger the test a bunch of times and get like the failure to appear. And I didn't. And that would be useful. So let's do that. So what I'll do is, first of all, do I still have this patch in my tree somewhere? I do. I'm going to rebase this on central. Who's going grrr, Smurf D? Smurf D is saying that they're going grrr. Who's going grrr? And then the other thing I need to do is I need to update the test so that it's no longer disabled. So I need to remove this stuff. What I'm going to do is I'm going to run this on Linux. So in the ideal situation, like I might be able to even capture this in like Pernosco, which is a tool I think I may have talked to some people about. Sublime test browser ini delegate. We're just going to remove these skip if rules. And then, oh, hang on. Oh, I rebased, but I did not update to the tip. So let me update to the tip. And yeah, we're just removing that. So we're going to amend. And I probably have a mock try fuzzy. How did I do it before? I did like mock try fuzzy Linux Fission, because that's where it was failing on, Linux Fission. And what I'll do is, instead of waiting for me to like come back and manually trigger it, I'm going to say, you can do mock try fuzzy and you can tell it, hey, I want you to rebuild like 20 times. Rebuild. And we're not going to use an artifact build. Oh, hang on. And I also want to pass the directory that I want to run, which is doc shell test browser. Scooby-Doo. Scooby-Dooby-Doo. While we're waiting for that to show up, let me just quickly check the chat, make sure everyone's still okay. Oh, the person who got the bugs assigned. So I'm not assigning mTiggly the bugs. I'm just asking for information. So hopefully it's okay. I hope I'm not bugging mTiggly too much. But good point. Sometimes mock try fuzzy takes a while. Any of the sort of like mock try jobs or commands that try and like come up with the list of things that can possibly be built can take a while, because it has to like generate that list on the fly based on a bunch of Python, and I think that is intense. Like I can hear my fans spinning up because of it. While we're waiting for that, I can try and answer some questions. So these are some questions that were left over from last week, and I never got to answer. How is gbrowser and XPCOM used? Can you talk about it too? Sure. So let's start with gbrowser. Yeah, it's so Danny Colin says it's running on 3.9. That is correct. Whoa. Yeah. Mock is running on 3.9. I think we've mostly switched all of our Python over to Python 3.9. Linux 1804, 64, and then what was the build type I wanted to do? Fission, opt. Yeah, this one. Not asan or debug, but opt. Okay. Run. Oh, you know what? It's going to be mad because I have not added my SSH key. Yeah. Okay, so that's annoying because I just recently restarted my computer, and so my SSH key, I need to authenticate it and add it and authenticate it again. But the good news is that mock try remembers the thing that I just tried to do. So hold on. And I go mock try again, and it'll just like retry the thing I just did without having to like rebuild the list, which is really handy. So so that can go up. Okay, so let's talk a little bit about gbrowser and XPCOM. Well, those are two very different things. So I'm going to start with one and then talk about the other. So let's talk about gbrowser, and then eventually we'll talk about XPCOM. What is gbrowser? Gbrowser is the name of the component in the Firefox, in a Firefox window, browser window, that manages tabs and the underlying infrastructure for switching tabs, adding tabs, knowing about tab switches, etc. So it's a pretty big deal. It's probably one of the more complicated components. And in fact, I believe we have a little bit of documentation on it. Let's see here, gbrowser. Do we have? So, yeah, it's very minimal documentation except for the async tab switcher, which is documented. Light documentation right here. And you can think of gbrowser is an instance of a component called tab browser. Window global instance of a component called tab browser. And that's why this thing is called tab browser. And you get one per window. There's one gbrowser per window. And so if you ever like build a Firefox, here, let's manipulate a Firefox and we can start checking it out a little bit. So let me just do a quick artifact build. We'll bring it up, we'll bring up the console, and then we can start messing around with it a little bit. But gbrowser is a window global that's a variable that's available in the browser window scope, and what it's doing is it's referring to that Windows tab browser instance. Okay, and that means that gbrowser is really powerful. You know, that's your gateway for adding tabs in a window, for removing tabs, for switching tabs, for you know, it does a bunch of stuff. Like sometimes the things that gbrowser does is more than, like, it's not necessarily related to tabs, but it also, like, it's a sort of a central place because it's like one of the biggest, if you think about it, like with our web browser, the fact that you can switch tabs and then this content area updates and all of these toolbar items update depending on like which tab you're in, and like all of that state management is managed by tab browser. It's a pretty important part of what a browser window does, and it's kind of become this dumping ground, I think, for various browser functions. I think that gbrowser is a bad name for it. However, gbrowser is a pretty bad name for what it is. Could maybe be called like G tab manager, or like G browser manager, window browser, no, browsers manager, because it allows you, like, what is a browser? What is a browser? A browser is similar to an iframe in that it's a browser element. If you look at the DOM, actually, is this build done yet? We can take a look at it. This will all make more sense whenever we have something we can play with. Okay, so we have a browser window. Let's open up a couple tabs. Let me open up some Pocket Stories, something like that. Hold on, I'm at a breakpoint for some reason. Why am I at breakpoints? Disable all my breakpoints. I don't want breakpoints. I must have been doing some stuff. All right, let's say I've got some tabs. Why am I hitting breakpoints? Stop hitting breakpoints. Okay, let's say I'm at some tabs. And we get the console, we can see that one of the things that's available to us is G-Browser. Now, let me start by saying what is this G? So that's an old Mozilla convention in our both in our C++, I think, but in our JavaScript as well. G stands for global. It's a way of indicating inside of the variable name that something is globally scoped. In this case, it's global to the window, the browser window. Like, this browser window is distinct from this browser window, obviously, and each one has a G browser. This one has a G browser, and this one has a G browser. And, you know, they can talk to each other. We can pass tabs back and forth, for example. But the G is global for a particular browser window. But every single tab in here will be managed through this Windows G browser. That's the first thing to know. And the G stands for global. And we have other conventions like that. Like, you might notice that some of our arguments and functions will start with A. Like, let me find some examples. You can really see it in some of our older JavaScript too. Like, let me find some old JavaScript. Well, heck, like the tab browser code. Let's find some functions here. Old functions. Like A URI, A params, A index, A flags. That A stands for argument. And that was a way of like differentiating between G is for global, A is for argument. It was a way so that, like, if you were looking at a variable, you can get a sense of what scope it's in. And A would be like, oh, it's function scoped, or method scoped. M is for method. S is for static. I've seen like K is for constant, global constant. But I've also seen all caps for global constant as well. Yeah, so these are just conventions, and these conventions are really old. Like, before I showed up, more than 10 years ago, maybe even before Mozilla existed, maybe from back in the day from Netscape. So it was before you had things like name spacing. Maybe you had different ways of like better practices for declaring whether something is a global or an argument or a method or something. These are like, this is the old school way of doing it that Mozilla has just kind of gotten its DNA. And we do it kind of on and off to this day. Like, I'll still see people landing patches where they use A in front of their arguments, and sometimes we don't. And I can't say that I care either way. Like, it doesn't really help me, at least in the JavaScript land. But it's a convention that's kind of like poorly enforced, and it's questionable whether or not it's actually worth doing, at least in our JavaScript code. Okay, so that's hopefully going to explain what G is. What is a browser? Just so we're clear, a browser is an element, a Zool element, that knows how to render web content. So all of this stuff in here, the stuff that I'm highlighting, all this flashy stuff, this is an HTML document. It's loaded inside of a browser. You can think of a browser very similar to an iframe. You can send it to a source, like you can navigate it, but it's got more powers. Like, as the person who is managing a browser like element, we can like tell it to do a lot more than you can tell an iframe. Like, under the hood, browser and iframe are using the same infrastructure, but a browser has more powers. You know, we can do a lot more with a browser element. And so back in the day, there was only one browser per window. Wait, hold on a second. There's a question. Jonathan Lindsay asks, I've seen a person use a whole lot of Firefox windows and not use tabs as intended. Is the G browser why the RAM usage goes way up in that case? I may not have been following because I'm working. Sorry. There's so it's hard to say whether or not that's related to memory going up. You can think of like memory going up, or the browser is slow, or it's janky, or it skips frames, or it's like these are almost like the sorts of they're real problems, but it's the same kind of problem as like a stomach ache or persistent headache or something, where if you go into the doctor's office and say, I've got a stomach ache, could it be from this thing that I ate yesterday? It's like, well, we don't know. Maybe, but it could be any number of things. You might have a tapeworm. You might be having a cramp. You might have an ulcer. You might have heartburn. Maybe it could be all sorts of things. We have no idea. The only way really of knowing is measuring. So if you have an instance where you have like a person with lots of browser windows and they're consuming a lot of memory, then you can take a measurement using about memory, and that might help get a sense of where all that memory is going. If you go to about memory and take a measurement, and you can like examine that, and you can post it to Bugzilla. One thing to note though, whenever you have many windows open, is that they're all visible. Like one of the optimizations that we do whenever a browser has tabs is that we know that there is a foreground tab and a background tab. So for example, this background tab, whenever it goes into the background, like all of the graphics stuff for it, we throw it away because we don't need to paint it anymore. We retain the page, it's still loaded in the background, but all the graphic stuff gets thrown away. All of these background windows are still technically visible. And so we keep that stuff in memory, the graphics stuff. And because they're all foregrounded in their windows, they're all running at like full 60 frames per second. Background tabs we tend to throttle them down a little bit. We reduce the amount of cycles we give them. We reduce how much, how many times we let them like tick the paint loop because they're not actually visible. But because all of these background tabs are technically visible, they're all running at 60 FPS. Like we're refreshing them as fast as we can, and they're all the graphic stuff is loaded into memory. So that might be related to a person who's seeing more memory, more memory usage because they have a bunch of windows open. Jonathan Lindsay says, if the windows are minimized, does that make them invisible? Yes, it does. If you minimize the windows, then we throw the layers away. We throttle things down because we know that the user can't see them. On Mac OS, actually, we have an optimization because of something called window occlusion. So if a window is fully covered by another window, then we know it's not visible. So this background window, for example, we will throw its layers away whenever it's all covered up, and we'll bring them back. We're pretty good at like making sure you don't see the any kind of flicker, but like we throw the layers away whenever the window is occluded. We do that on Mac. I don't know if we have the same mechanism on Windows. We can actually check. I'm curious myself now. Occlusion here. Hang on. DXR occlusion state. Is that what it is? Occlusion state. Oh, we do have a window occlusion tracker. So at some point we added window occlusion support on Windows. And when was this? Sotaro added it. Oh, like just earlier this month. Add support of window occlusion on Windows by disabling it by pref. So it sounds like this is something that we're like currently working on, is window occlusion on Windows. It sounds like we have to like track it ourselves. Like on Mac OS, the operating system tells us whether or not a window is occluded or not. Is like we get events about it. Whereas here, I think we have to like track it ourselves. And I don't know what the preference is here. What is the pref? It probably have been added to the static pref list, and it's called widget Windows window occlusion tracking enabled. It's currently false, it looks like. Well, that would be my guess, is that it's currently false. Yes, currently false. And someone asked whether or not Linux has it. I'm curious myself now. I would guess probably not, but you never know. Stransky from Red Hat, who basically owns the widget layer at this point of Gecko, he's pretty prolific. So let's see. Window occlusion. Windows. I don't see anything for GTK. I think they're focusing mainly on like getting onto Wayland and making sure Wayland works properly. Maybe Wayland will give us some occlusion stuff, but I don't see. Let's say GTK occlusion. Yeah, nothing. So I am reasonably certain that we do not have window occlusion state change support on Linux, but maybe someday. We're getting it on Windows, so it could happen. Wow, we got really sidelined, but that's kind of what the name of the game is with Joy of Coding. We we'll answer questions as they come. And did my what was I was answering this question? Yeah, sorry, I got distracted. GBrowser is a terrible name. If we had a second shot at it, we might call it GTab Manager or GTabs Manager or GBrowsers Manager, because it's managing multiple browsers, like multiple. Here, let me close some of these windows because we have a bunch of windows open now. It's managing multiple browsers, and by browsers I mean those elements again, like these things. There's one per tab. One browser element gets created per tab. There's a one-to-one relationship there. And so GBrowser or tab browser, its job is to manage both the tab elements and switching between the different browser elements. And there's another piece of the puzzle here, which is that Firefox used to not have tabs, or at least Navigator didn't. The Netscape, the Mozilla browser, Mozilla Navigator, whatever they called the browser, in the Mozilla suite. What was the browser called? Was it just called browser? At least the Mozilla suite, when it first came out. Well, I don't know if that's true, but like at some point in its lineage, Firefox didn't have tabs. It was one browser per window. And then, and this is long before I came here, but that individual browser element was called GBrowser. And that makes a lot more sense. That one browser element was called GBrowser. And then they wanted to add more tabs. They wanted to add tabs to it. So what they did was they reused the GBrowser name, and they kept the same API, but made it so that it proxies calls to it to the selected browser, the currently foregrounded browser. And the reason for that, I think, I wasn't around for this, like they kept the same name when adding tabs. I think this was to make it easier to support Zool add-ons that relied on touching GBrowser. The new GBrowser variable had the same interface as the old one, but would forward calls to the currently selected browser. And I'm reasonably certain that's why it's called GBrowser. Going back to occlusion state change for a second, we got an update from Danny Colin. Thank you, Danny Colin. I wish this was like I had like news music, and I could like, over to you, Danny Colin, and we could bring you up almost like with the weather or with like breaking news. But breaking news, boop, 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 breaking news. Occlusion state change support for Wayland has been filed. It was filed 8 months ago, and it sounds like they're waiting for Upstream to implement a protocol to support surface occlusion. That is your update for months ago, a proper protocol was underway here. I don't know where it's at now. I am not familiar with this. It looks like it was last touched 2 months ago. It's wild that this is they're using GitLab. This is wild. It's been a while since I've looked at freedesktop.org. I didn't realize they'd gone to GitLab. Cool. At any rate, that's your update. It might come whenever Wayland has surface occlusion support. That has been your occlusion state change update. Boop, 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 boop. All right. So hopefully that answers your question about what gbrowser is, the first part of the question, what it is. Now, what can it do? It can do a lot. gbrowser has a ton of methods implemented on it. And like these are some of the ones that are like forwarding. Like, remember I was telling you that we kept, whoever did this kept the same interfaces before, but made it forward to the underlying selected browser. This is that happening right here. Oh, Amy JPEG asks, what is the matrix channel for the stream? Great question. If you go to the agenda, there is a link down here for the chat, and I will copy that link and drop it in. But I can see your message. Like, you're in the matrix chat by being on. Hang on, how do I get this link? Come on. By being in the Twitch chat, I've bridged the two. So you don't have to join Matrix if you don't want to, but you're welcome to. You're welcome to. And there's documentation in the agenda on how to join. And if you want a link to the agenda again, just scroll up further in the Twitch chat, or even better, let me just supply that link again. Boom, there you go. So scroll down here, check out this chat section. Hopefully that'll answer your questions. And if not, let me know. Okay, so that's a big bunch of history on gbrowser. I wanted to just point at some of the complexity of this thing, because this class, it's a class, I guess. Yeah, it's an object with a bunch of methods on it, so it's kind of like it's more like a struct than a class. We don't instantiate with new or anything, but it's massive. It is massive. It does a lot. It does a lot. Like, look at this thing. Look at the size of this thing. It does so much, and it's like creating browser elements. It does it lazily for session restore. It handles discarding them if, for example, session store doesn't need it anymore, or you're doing like lazy unloading or unloading of tabs that are taking up too much memory. There's a lot of security stuff in here to make sure that when tabs are opened, they've got the right like security principles and methods for removing tabs, like all the stuff that powers like right click and like close multiple tabs, close other tabs, close tabs to the left, close tabs to the right. It's all managed from within here. What else happens? Replace tabs with window, adopt tab, move tab, multi-tab select. Did you know you can select multiple tabs by holding shift? You can. You can select multiple tabs and then you can like close them or something. So for example, I could like select these two, right click and close them. Did you know you could do that? You can. That is something that Tab Browser supports. What else does it do? Handles a bunch of events. Here's the occlusion state change stuff, where we tell whether or not we should preserve layers if the occlusion state changed or if we have minimized. Apropos of that memory stuff, it's kind of wild that we ran into this. Kind of like a nice idiosyncrasy there. Or not idiosyncrasy, a coincidence that we happen to run into this code when, it was Jonathan Lindsay kind of asked that very interesting question about memory in multiple windows. Yeah, I think that's all I'm going to say about gbrowser. It does a lot, and I invite you to read the source code to see what it does. I wish it was better documented. It is not, but if you want to read it, here is the source code for gbrowser. But I think I've given you the sort of the salient details of what it is. It is a thing for managing browsers and tabs in a window. And it is understandable. Yes, it is very long, but each one is like more or less independent of one another, and they're relatively well named, what the methods do. So you can check it out, and you might be really interested in some of the stuff it can do. And I guess we also implement the tab context menu in here. Okay, great. And then XPCOM. What is XPCOM? can we talk about it? This stream is becoming a lot of questions, but I think that's okay. If people are finding this interesting, I'll keep going. But if people would rather I like hack on a bug, I can do that too. But I'm gonna start trying to explain what XPCOM is, very briefly, because it's kind of complicated. XPCOM was Netscape / Mozilla. Was it Netscape, or was it Mozilla's? I don't remember when it was introduced. Either was it during like the Netscape days, or after Mozilla spun out into its own organization. But let's say it's a very old Mozilla technology modeled after. Am I spelling that right? What? Modeled. That's how you spell that, right? Modeled. Model. D-L-M-O-D-E-L-E-D. Past participle. That's a word. Modeled. Come on. Past tense. What? All right. Well, anyways, that's a real word. It's a very old Mozilla technology modeled after COM from Microsoft. So COM was a sort of a pattern that Microsoft developed. It's still, I think, in use to this day. You can write COM applications using COM. And it's quite verbose. It's quite verbose. It reminds me sometimes of some stuff I've seen from my Java days. But what it effectively allows you to do, like there are a couple of big parts to it. But though, here's the way I think of it. Scar Gabry is spamming the channel with some kind of garbage. So feel free to kick that person. I don't want any spam on this channel. Shame on you, Scar Gabry. Okay. The first thing to think about is it's a pattern for defining interfaces. Pattern? Is it a pattern? It's a like infrastructure, more like. It's not a design pattern. It's infrastructure for defining interfaces for components that are implementation language agnostic. This means a component can be written in... This means a component written in language A can, in theory, talk to a component written in language B by way of an interface defined in an IDL file. So, you know, this is what we would call a binding, the ability to bind two different things, two different languages, things written in two different languages together. It's called a binding, I think. And what IDL, XPIDL, I'm going to put that in quotes because like it's called XPIDL, but the actual files end in .idl. Let's actually take a look at a .idl file, and I'll show you what I mean. Let's look at a simple one. Let's pull one up. Moz DOM window. Oh, this is very simple, like vestigial menu builder. Okay, this is a very simple interface definition file. And if you remember from Java, if you've ever used like Java before, there's like the notion of an interface file or an interface. It's very similar, where you have this language that allows you to define the sorts of things something exposes for consumption. You know, and in particular, what types of things, like these are methods. So a thing that implements this interface must implement this method that takes a string and returns void. It takes these things in and returns void. And in this case, it must implement this function and return a string. And these interface definition files are consumed at build time and turned into the binding layer. It's like turned into basically C++ for communicating between different languages. Or in particular, I make it seem as if like there are a bunch of parts of Firefox written in a bunch of different languages. It used to be the case. The dream was that Mozilla-backed applications could be written in whatever language you wanted, so long as it supported XPCOM. So if you built in XPCOM support or XPConnect, which is another technology that I think does the reflection back and forth between languages, you for example could have written an XPCOM component in Python, or one in Java, or one in Lisp. Who knows? So long as it supported XPCOM, XPConnect, if you like built that support, then you could write a component written in that language. But these days, practically speaking, XPCOM components these days are written in C++, JavaScript, or Rust. These are the three ways of writing XPCOM components. And what XPCOM allows us to do is it allows us to speak between these components without caring what's on the other side. It could be C++ on the other side. It could be Rust. It could be JavaScript. It doesn't matter. XPCOM kind of just like takes care of it, which is pretty incredible, especially for something back in the day, because like there's like a lot of magic happening under the hood of like translation between languages. That's what XPConnect is. It's like the work of reflecting things like types between languages, and when you pass arguments, it like will turn those into the sorts of things that the other language can then understand, because it might have its own like internal notion of what a number is, or like a string. So yeah, that is kind of what XPCOM allows us to do. And then XPCOM offers us a registry of XPCOM components and XPCOM component singletons called services. XPCOM component singletons, where there's only one instance per process, those are called services, and we have a bunch of those. And the way you get at these things is through these globals that are available in privileged JavaScript, and you'll often see them look like this: components.classes. Sometimes oftentimes these days that's actually shortened down to CC. But that is a shortcut to components classes. You'll also see CI for components interfaces, and you'll see invocations like this. Let's see. Let's see if we can find an invocation. Here, perfect. So this is just an example XPCOM thingy. I don't know if that's rendering right. Lang JS. Is that rendering right? Let's take a look at how that's showing up on the agenda. Scooby-Doo-Doo. Nope, that looks like garbage. Let's see here. Does it understand this? Wow, why isn't any of this rendering nicely? I would have thought that Markdown would just kind of be consumed. Oh, is it because I'm using... You know what? It's because I'm using the rich editor in... I need to use like the... Yeah, this is what I need to do. That's what's going on. Oh boy. Yeah, hold on a second. This is Joplin. I'm really struggling to make this look good. You know what? I'm gonna fix this up later. Let's not get distracted. So this is an example of an invocation of like getting an XPCOM component instantiated. That's what this is doing, and it's very verbose. But think of it like this: you can think of CC as this map of factories, effectively. So the key to that map is this unique string that identifies the factory that there's the key value mapping, and like the key is supposed to be a descriptor for what the factory provides. And it starts with @mozilla.org because I think the original dream was that, different institutions, maybe if you're building like an old school binary add-on for a browser, or you're building an application using, some Mozilla technology, but some of your own, you might want to like differentiate it by having your own institution's name in here, or some kind of like identifier. So I could have had like mikeconley.ca/my special ID or something. And I think this is supposed to be a version number. A lot of this is like old school convention that we've just stuck with forever, and it doesn't make sense these days, but that's what it's for. But basically, this is a map lookup to give us a factory. In fact, if we go back to our browser here and we open up a console and we just do that, what we get is this thing. And this is the factory effectively. And it's got like this unique user UUID, and then it's got these functions: create instance or get service. And because we know that we want an individual instance, we don't want the a single instance per global. We want to create an individual instance. We can call create instance on it. And what it will do is that factory, if one exists somewhere, if someone has registered a factory for that particular key, will return an XPCOM component that implements this interface. There's an interface called NSI refer info, and then we'll get it here, and then we can call stuff on it using the XPCOM interface. Very complicated. And whenever I was first learning this stuff, it was like, holy smokes, that is a wild way of doing this. But it was based on a pre-existing pattern that Microsoft developed called COM. No. What is it? Microsoft COM. Let's look that up. Microsoft Component Object Model. COM. Like, it's very, very similar to COM. And let's look here. You have some interface, and then it implements. You can like subclass it, and then you can create an instance, and you pass the interface that you're expecting to the create instance method, and then you get it back. And the other thing that's worth noting here is that whatever you get back, you don't actually know what it is. All you know is that it implements an interface. And that's part of the power as well as the strangeness of XPCOM, is that there's so much hidden from you. You don't really know what's on the other side. You just know that you've been given back a thing that implements this interface. You don't know what language it's been implemented in. You don't even know if it implements other interfaces. You could find out. You can query it to actually see if it implements other interfaces. And that's called query interface. So if you are holding a JS or an XPCOM component or an object, you can call .queryInterface on it with an interface, and if that returns you something that is not null, that means it implements this interface as well. So a thing can implement multiple interfaces, and then you can like ask this sort of like mystery object. It's almost like it's wearing a mask. You don't know what it is, but you say, "Are you also one of these?" And it can go, "Yes." And you still don't know what it is or what it's implemented in. And in a way, you're not supposed to care. You're just supposed to go, "Oh, okay, good. You implement that interface. I'm going to call this method on you. Hopefully, you're going to do what I want you to do." So the interface is kind of a contract, and so XPCOM is a pattern. There has been a lot of work to decontaminate, is the terminology that we use, to decontaminate. Decontamination of the Mozilla source code to reduce all of the XPCOM that we're using, because it's very verbose. There's performance overhead, especially when you're passing stuff back and forth between the C++ and JavaScript implementations. If you do it very, very frequently, there's the attacks effectively by crossing what we call the language boundary or the XPCOM boundary or the XPConnect boundary. There's attacks to convert things back and forth. And there's better ways actually of exposing things that JavaScript can call native code from. And what we do is we implement a lot of those things using what's called a web IDL bindings instead. And those have like a similar interface language, and it generates similar C++ for making it possible to call into C++ from JavaScript very easily. But there's a lot less overhead. Now, one of the other things about WebIDL is it doesn't allow us to implement WebIDL bindings or WebIDL interface implementations in JavaScript. You can only implement them in Rust or C++. In fact, I think it's only C++. I don't know if you can implement a WebIDL component or a WebIDL interface using just straight Rust. You might have to go through C++. But the thing is, you can't implement one in JavaScript. You used to be able to, but you can't. So it's kind of a one-way street with WebIDL. Whereas, with XPCOM, it's a two-way street. C++ can call into JavaScript, which can then call into C++, which can call into JavaScript. You can kind of go both ways. In fact, remember that test we were looking at? Oh, hey, we got our test failure, I think. Test unexpected fail. That's not what we wanted. These are test failures that are unrelated. This is the one we wanted. So this top-level navigation delegate, this is an example of an XPCOM component. Let me actually pull up the source and show you. We have an interface for it. It takes just a single method. And then we've got some C++ inside of DocShell, which tries to get access to something that implements this interface and then calls this function called shouldNavigate on it. Well, lo and behold, if you look at the test for this, you can implement that interface in JavaScript. And in our test, that's exactly what we do. We implement the interface in JavaScript right here. We say this thing implements this interface. This is how you do it in JavaScript. You say that you implement basically the query interface method on it. And because we say, hey, yeah, we implement this interface, and then you actually implement the interface, C++ can then call into this JavaScript code, which is pretty wild, That's really powerful. You have these things kind of talking back and forth. So that is, I think, all I'm going to say about XPCOM. I really have to clean up this document. I'll do it. Well, this is garbage. I will do it after I'm done streaming. But hopefully that answers your question about XPCOM and gbrowser, whoever asked that. You know what? I don't think I'm going to get to these two. And maybe I'll answer this one next time. What I want to do is, if I can, take a look at this test failure that we've got a log for now. Test unexpected failure. So the test failure is occurring because we fail to see a load attempt when we expect to see a load attempt. And that happens, that failure occurs on line 40 of this test. So let's pull up that test. Oh, that is a helper method. Is there a stack? Does delegate for 40. Well, there's not a stack, unfortunately. But what we can do is we can look at the log messages and see where it got to. So here's the actual test. Do we get to checking that we don't delegate? Checking that we don't... No, we never get there. But we first load example.com. That happens here when we create the tab. And then we saw the load of com. We saw now an attempt to load example.org. That happens here. And we expect it to delegate. Org, browser context load URI, sent to content child. We received it, saw a navigation attempt, and then we say, hey, false. Navigation delegate is returning false. Test top level. It's returning false to say that, hey, this thing should not navigate. So that's good. We should be delegating. And then we fail. Oh, we see a pass for delegated navigation to example.org. So that's good. So that was the first one. And then we try going to example.org 2. Saw the load event, load attempt. So we fail does delegate for on line 40. We failed this assertion. The parent actor should have been sent the string, but maybe it wasn't sent it in time. Because like we send this message and then we dispatch this event, top level navigation delegate event. We wait for the content event. Should navigate, should have been received here. And we should push the message data URI string here. But we don't. You know what? That's the other half of what we should have done. We should have said some logging here, like top level navigation delegate parent received message, message.name. Well, I guess it'll always be should navigate. There's only one message. A message with URI and then message.data.uri string. And then the other thing we should do is dump out the seen URI strings. Parent has seen these strings. JSON stringify. Yeah. And this failure that we're dealing with here. Oh boy, what is the bug number again? Top level navigation delegate intermittent test timeout. Is this a test timeout? This is an unexpected fail. Here we go. Here's a test timeout. So this is a slightly different matter. So there might be actually two problems in here. So we've added logging for one problem. Here's the test timeout one, which is what was originally filed for. Okay. We see the load attempt for the original tab. All good. Then we load example.org. Yep. We delegate for it. Then we try to load this page. We receive the load attempt. We delegate for it. Then we attempt to load this page. And we delegate for it. Okay, so that's, I think, good. We were supposed to delegate. And then we want to make sure that we don't delegate for example.com. That's how this test works. So attempting to load example.com, asking browser context to load URI example.com. We've loaded the URI, received the load attempt, saw a navigation attempt to example.com. We're going to allow it to load. And then we see a DOM content loaded event with this, which is from back here. This is the DOM content loaded event for this document. Load. Which is weird. We shouldn't even be allowing it. Huh. Does not delegate for... Then we just kind of wait. Awaiting loaded here. Where is that? We're awaiting for this event. Waiting for a hash change event? No. We're waiting for the browser to load. Attempts to load example.com. That's here. We do the load. Child receives the message to load it. And then we get this old DOM content loaded with the old we have loaded that. See, we receive the load URI and we say, don't do it. Do we? DOM content loaded. Is this event fired? Doc shell, DOM content loaded. Dispatch. How do we fired? DOM content loaded, document ready for idle. I'm trying to find the place where we dispatch. Oh yeah, unblock DOM content loaded. Dispatch content loaded events. Document has been loaded. And the DOM content loaded, like the browser test util stuff on this side of things, DOM content loaded. It's getting at the document URI. It's fired on the document. And the document URI and visible URI location, blah, blah, blah. No, sorry, wrong. Yeah. Event DOM content loaded with URI, invisible URI. So like, why does it think that these are the current document URI? Do we have a timing issue here? Get document URI. This is we get the M document URI. M document URI equals when we set the document URI, and when is that set? When we handle same document navigation. On location change. Update URL in history. If the document URI change update fire language, so the browser address bar gets updated, the back button is nailing. This happens when we are updating the URL and history, and that happens when we call document.open or when we add state. Does delegate for. Let's look at the order of events here. We start the test. We see a navigation attempt and return false for the first one. For org. Why didn't we see one? When do we register this thing? Register. Oh, we register it here. Okay, at the very start, like after we loaded this, we wait, do we register? And then the very first thing after that is, yeah, we've got this thing set up. Our registered delegate sees those, the first event to COM, saw.org, saw.org 2, you know what I'd like to do is try and reproduce this with Pernosco. Reproduce this failure in the Pernosco app. This is exactly the sort of thing I want to do with Pernosco. Test name, this one. Number of reproduction attempts. Let's try and do it 15 times. Let's use chaos mode. Reproduce. All right, so we're going to see if we can get this in a Pernosco trace, because if we can, we might be in good shape, because I can maybe see why we're firing that event. Pernosco is something that I had talked about. Oh, hang on a second. I'm seeing some commentary. Are there any docs in XPCOM? When I go to Firefox source code docs, it starts with logging. And then someone linked to this. XPCOM collections, XPIDL, XP. So yeah, our documentation for XBCOM is pretty poor for Firefox source docs, but it does exist. It just hasn't been properly ported yet. So there's a bunch of old documents on XPCOM that were on developer.mozilla.org, but they got archived because we made developer.mozilla.org about just web development in general. We took all of the sort of Mozilla technology stuff out of it and we put it in this like archived content GitHub repository, and we need to like port all of this stuff. But there is documentation in here. It's just, it needs to be converted. See if there's anything in here about XPCOM. Mozilla Tech XPCOM. Yeah. Mozilla Tech XPCOM. Here's a bunch of stuff, and it's like very poorly very like this. A lot of the stuff's really old, but the documentation's in here, but it's just the raw HTML. We need to like go through it and convert it. Like here, this is how to create a Python XPCOM component. Wah! Like let's briefly check out this document. I'm gonna just drop it into a document viewer here. What was the old? Provides a tour for making a simple JavaScript C++ component. So yeah, there was a book called Creating Applications with Mozilla, which I guess this website doesn't work anymore, but Creating Applications with Mozilla. You want to learn about XPCOM? Get this book. It talks about a lot of the old technology. Who wrote this? Hey, I know some of these people. And you can build PyXPCOM, which is, I guess, the native library for Python that allows you to bind to XPCOM, and then you import it, and then you can define a simple IDL file, and then you can compile that into the special binary format for it, and then you can implement the component by using this very strange form, but then you like implement the interface, write, change, etc. And then generating implementation templates. And then I guess there you go. You've got you got yourself an XPCOM component. I don't know, but like the documentation is in here. And it needs to all be converted. In fact, if people are looking for interesting volunteer opportunities, porting documentation, interesting documentation from this this GitHub repository is very noble and something that we should be doing more of. Help us port documentation from here. So here's how I would do that. First, find the documentation that you want to port in the GitHub repository. Then you want to file a bug. We just did this recently for bug SJS. No, server Firefox source docs. Here. Here's an example of a bug where we ported some of the work over, the documentation over. And there's like a tool called Pandoc, which you can actually just follow these instructions for how to like convert to an RST. Follow these instructions to convert the document to an RST file. And then you can use this as a template, use this example as a template. And then what you want to do is file a bug blocking meta documentation source docs. Yeah, port archived MDN. File a bug blocking this one. File a bug blocking this bug. And then post for review. And that would be great. the more useful. So part of the challenge with doing that is that a lot of this documentation, like there's definitely some interesting documentation in this folder, in this GitHub repository, but there's a lot of it that's way out of date. And I think it's arguable that sometimes out of date or incorrect documentation is worse than no documentation. But like, it might be worth just kind of like leafing through here, maybe under Mozilla, in particular Mozilla Tech, and like going through some of this stuff. And if there's anything in here that you're like, hey, all of this is still really relevant or looks relevant, then filing a bug and getting it ported to Firefox source docs, which is where it shows up in here. It gets built, it lives inside of the source control, and then it gets rendered nightly. I think we do a build of it and host it here, which is far better than putting it on the wiki. So if you're looking for volunteer opportunities, this is it. This is one. This is one way of doing it. Okay, I think I'm going to end the stream here. Hey, thank you so much for watching episode 267 of The Joy of Coding. I know we didn't work on too much stuff. We started to get into some interesting stuff with that test. I'm interested in knowing whether or not Pernosco is going to come back to me with the test failure reproduced. And if so, then that would be very interesting. Maybe I'll hold off on examining that Pernosco trace until next week. But we shall see. I want to thank you again for watching episode 267 of The Joy of Coding. Let me know what you thought of the episode. There is a form at the very bottom of this poorly formatted agenda. I will clean this up, but click on the rate this episode. If you have questions that you want me to answer or feedback about the stream, let me know. I'll do my best to accommodate you. And with that, I think I'm going to call it a day. So thank you again for watching episode 267. Have yourselves a great day. Take care. Bye-bye.
The joy of coding.
See ya.